Hi, science friends. We are learning to name just a couple more things today, and this will wrap up our naming that we've been working on this week. So, everything that we have named up to this point are binary compounds. So, they just have two different elements in them. So, like sodium chloride or diphosphorus pentaoxide. So, they have two parts to them. Today, we are going to talk about naming ternary compounds. So they have three different elements in them. Usually one is a polyatomic ion. So you should have this sheet in your binder. You'll want to pull that out as well as your periodic table. I told y'all you were going to get to be best friends with that periodic table. So this is our polyatomic ion reference page. So like your periodic table, this is something that you would use on your test. I don't expect that you memorize these, although when you get to college, you have to memorize these. What you see here is mostly anions. So you'll notice that most of these polyatomic ions have a negative charge, but there is this one lone cation that has a positive 1 charge. So, for example, chlorate. When we see chlorate, it is ClO3, and it has the name chlorate. So you kind of have to look out for these guys, these polyatomic ions. And that whole thing, ClO3, has a negative 1 charge. So if we were going to write the charge on it, you would write it like such. The negative 1 is on the whole piece, okay? So let's do a little bit of practice. Let me draw your attention first to this one and this one. I changed a couple of things in the formula because I had actually written them incorrectly. So please make those changes on your notes page as well so yours are written correctly. So basically these guys are going to follow the rules of an ionic compound because they still have ions in it. The positive charge and the negative charge. So lithium, for example, if you look on your periodic table, is a +1 charge. And then you should see this guy. When we look at him, it's a ternary compound because we have lithium, carbon, and oxygen. But carbon and oxygen go together to make a polyatomic ion called carbonate. So if you look on your reference sheet, carbonate has a -3 charge. So like we did with ionic compounds, we are wanting these charges to cancel out, okay? So basically we crisscrossed and put that 2 down here. This one, you don't see it, but it's gone over here. So we have 2 +1 charges, 2 +1 lithiums to balance out the 1 -2 carbonate that we have. So we are simply going to name this lithium carbonate. Notice that I didn't change the ending, didn't change the name. On these polyatomic ions, you name them as they are, okay? So you don't have to change the name on them. Let's look at the next one. So our first element is calcium. Calcium has a +2 charge. And then nitrate, if you look it up, has a -1 charge, okay? Notice that we've moved the 2 down here, put a 2 on the outside to give us 2 of those -1 charges to balance that +2 charge on calcium. So we're simply going to name this one calcium nitrate, okay? The next one, the first element is chromium. Chromium is a transition metal, so we're not sure on the charge of it, okay? So like in our ionic compounds, we're going to need to put a charge in parentheses before we name our last part, which is going to be sulfate, okay? Keeping that 8 ending on there. So if you look up sulfate, you'll see that sulfate has a -2 charge. Well, there are 2 sulfates shown here, okay? So that's going to mean that chromium also would have a +2 charge, okay? This here is a molecular formula. It hasn't been simplified as to an empirical formula. You notice, because otherwise it would be CrSO4, and you would simplify those twos out. Okay, but either way, whether it's written as empirical or molecular, you would still name it the same because the charge is going to be the same: chromium 2 sulfate. Okay, let's look at the last one here. So our first element is potassium. All right, potassium has a positive 1 charge. And the second one is permanganate, which has a negative 1 charge. So we'll just call this potassium permanganate, if I can spell. Okay, those charges cancel out, and it was pretty simple. All right. Just to clarify, you will notice that some of these don't have parentheses, like permanganate was not in parentheses there. Carbonate was not in parentheses. You can choose to write them with or without parentheses if you want. If you want to put it in parentheses all the time, that's technically okay. The only time you really have to put it in parentheses is if you're going to make multiple of them. Okay, if you're going to say that there's 2 nitrates, then you have to put that 2 outside in parentheses. Okay, technically, otherwise, the best way is to write it without the parentheses, unless there are the 2. Okay, so let's go on. You have a little bit of practice here. I'm going to write these as I work through them. So pause me if you want, and then you can check. Okay, so I've named these here: magnesium hydroxide, sodium chromate, potassium phosphate, and potassium sulfate. And I caught one of my own little errors. I frequently make these sitting on my couch without a periodic table in front of me, so I often get the charges wrong, so I apologize. But potassium should have a 2 beside it because it's a positive 1 charge, and we need to cancel out that negative 2 charge on the sulfate. Either way, it would still be written as potassium sulfate. Okay? Now, let's practice writing the formulas. So, this first one, we have ammonium and sulfate. So, ammonium is going to be written as NH4. Okay? That's got a positive 1 charge on it. Sulfate has a negative 2 charge. So, in order to balance that charge, I can crisscross my charges and put a 2 there on ammonium. Sulfate would be written as SO4. Okay? For the next one, we have potassium, which has a positive 1 charge. Chromate, which has a negative 2 charge. So we'll need 2 potassiums to balance that negative 2 charge of the chromate, CrO4. On the next one, we have calcium, okay, which has a positive 2 charge. Phosphate has a negative 3 charge. So if we crisscross those charges, calcium will get a 3 on it. Phosphate will be written in parentheses with a 2 on the outside. Okay, so I have 3 positive 2 charges. So that makes my total positive charge 6. And then phosphate is a negative 3 charge, and I have 2 of those. So that makes my total negative charge negative 6. And those balance out that way. Okay. The last one that we have here is beryllium, which is a positive 2. And hydroxide, if you find it on the table, is a negative 1. So we are going to write this as beryllium. And then we're going to have 2 hydroxides, okay? Cross your charges, and so the 2 is going to go over on hydroxide to balance that beryllium charge, okay? None of these were transition metals, so you'll see that none of them had a Roman numeral written after them, okay? All of them were just either metals or not metals and non-metals. Okay, so you have a couple here to try. Pause me if you wish, and I'm going to work through them, and then you can check yourself. Okay, so this is how these should be written. Silver and bicarbonate are +1 and -1 charges, so you don't have to have any subscripts on there. So it's just going to be Ag and then HCO3. Lithium has a +1 charge. Sulfate has a -2 charge. So you have to have 2 lithiums to balance that sulfate. So Li2SO4. Sodium and nitrate are both +1 and -1 charges. So those charges will cancel nicely, just leaving with NaNO3. Okay? And then the last one, barium has a +2 charge. Phosphate has a -3 charge. So we want to crisscross those charges, putting the 3 from phosphate on barium, the 2 from barium on phosphate, and it should give us Ba3, PO4 in parentheses 2. Okay? I hope you all did well on that. Writing the formula is a little bit trickier than naming the compound with these guys because of those charges and the parentheses and all of that type of stuff. I want to talk about one other thing, and they are acids. So acids, when you look at, I don't know if you talked about pH ever before at all, but we have a pH scale. The pH scale, and we'll talk about these more later in the year, goes from 1 to 14. So on the pH scale, acids are going to go from 1 to 6. Neutral would be at 7, and then above acids or bases from 8 to 14. Okay, so when acids dissolve in water, they release hydrogen ions, and they're electrically neutral, so they don't conduct electricity. There are 6 common acids that I'm asking that you memorize. So if you have some like index cards or note cards at home, or even if you don't, maybe you could just cut up a few pieces of paper and kind of make yourself some flashcards on these. So these are common acids that I'm going to ask you to memorize to be able to name. So HCl is hydrochloric acid. H2SO4 is sulfuric. HNO3 is nitric acid. HC2H3O2 is acetic acid. Phosphoric acid and carbonic acids are listed there. And what you will probably notice about these acids is that these all end in ic. Sorry, my screen's moving all over. These all end in ic, okay? But also, many of them have those polyatomic ions in them. So we see carbonate, phosphate, acetate, nitrate, sulfate, okay? And so, for example, sulfate has a -2 charge, okay? So you have to have that positive, hydrogen is +1. So you have to have 2 of those to balance the -2 charge on sulfate. So that's why these are electrically neutral. They don't have a charge on them, okay? Nitrate is a -1. Hydrogen's going to be a +1 to balance that. Acetate's a -1. Hydrogen's a +1. Phosphate here is a -3. So you have 3 hydrogens to balance it and make it neutral. And then carbonate is a -2. So you have the 2 positive hydrogens to balance it and make it neutral. So these are just ones that you commit to memory. There are many more acids and many more bases, but these are all strong acids, and I'm going to ask that you memorize these, okay? And that is all for that. That should finish out your notes for this unit. I am going to post in a Google form that's going to have some for you to practice naming, and then you have a couple from yesterday on those sheets that you hadn't been able to name yet that I sent you a remind message about. So make sure to go back and name those 5 or 6 that were there and submit those today. You all have a great day and have a great weekend, and you'll hear from me again on Monday. Bye.